Okay. So let's see if we can get in a little closer here. All right. So, a bell curve is data where most of the stuff is happening in the middle, and then you got some tails going off on the left and right. It's about symmetric. Can anybody think of a real life situation where a bell curve would?
IQ score.
Yes. Most people in intelligence are average. You got some people who are above average, some people who are below average. You got a few super smarties and a few people who are not so great in the IQ department. Okay? Pretty much anything about humans falls into this category, like height, weight, a lot of things like that. Most of us are bell curved out. That's why whenever you get like test scores back with like standardized testing, it always tells you like what percentile you're in, and that's based on a bell curve. So,
Pretty much all percentiles would fall under the bell curve.
not everyone, but most relating to human behavior and ability, yes. Right here in the center is mu. All right, with a darker pen so you can see. This one is mu plus 1 standard deviation, 1 sigma. This one is mu plus 2 standard deviations. And this is mu plus 3 standard deviations. Technically, this tail keeps going for like a really long time, like super thin. So maybe the average weight of a person is like, I don't know, 150, 60 pounds or something like that, right? And you got people who are above average, you got people who are below average, but you also have like people who weigh 900 pounds and they are off the chart, they're over here. So this tail doesn't end right here, it just keeps going. Does everybody understand? Okay, over here we've got like preemie babies who are off on this side who are like 2.5 pounds, right? That they are human, they do exist. So what should I write for this one? Mu? Minus 1 standard deviation. Here's mu minus 2 standard deviations and mu minus 3 standard deviations. Calculus actually tells us exactly what the percentages should be for a normal bell curve. This section is 34%, and this section is also 34%. All right, this is where I'm going to use my first color. Anybody want to use some of my highlighters, or are you all good? Okay, so I'm going to use orange for my center, so I want you to color. Doesn't have to be neat, we're just signifying that this is a color. And then up here I'm going to write that 68% of the data is within 1 standard deviation of the mean. They found out these percentages by using calculus. That's how you find the area under a curve. I think you should take that same color and kind of circle that 68%. you get it perfect, Noah?
Not entirely.
Nice.
Mostly.
Okay. Do you guys understand where the 68% came from?
From 34 to 64.
And do you understand what it means when it's within one standard deviation of the mean? What does within one mean?
Lots.
Right, it could be above, and it could be below.
All in that.
Right. All of this is at 68%. Now, my drawing isn't perfect, obviously, because this isn't 68% of underneath this curve, but it's not too bad. Next section, we're going to color, but first let's write out, this is 13.5% here. 13.5% over here. And I color this section a color. And this section. Okay, and then, so what percent of the data falls within 2 of the mean? 1%?
No, 1%.
So what percent is between my hands?
Oh,
I think so.
What?
27.
27 is the yellow.
90. Oh.
64, yes.
95.
95, right? Because the yellows add up to 27, but this is 68. So now I'm going to write 95% of the data is within 2 standard deviations of the mean. What do you think of this visual? Is this helping you understand it? Okay, so now what I want you to do is I want you to take my middle color and I'm going to underline the 95, but I'm also going to underline it with the second color because I want to show that like both colors make up the 95. Does that make sense? So for me, the yellow and the orange make up the 95. Okay. Last one is 2.35%. Make sure when you're coloring the last